Hey there guys, how's it going? Mike coming back at you here with another video for college algebra. In the previous video, we talked about polynomials. We did a quick review as to what they are, what those things look like, and then we did a quick recap of some basic operations with those guys, adding, subtracting, and multiplying. In this video, we're going to talk about factoring polynomials and what are the various techniques we can use to factor a polynomial into several smaller factors. So one of the easiest forms of factoring is to remove the greatest common factor from each term inside of a polynomial. This doesn't completely break it down into several nice things that we can work with, but it does make it a little bit nicer to look at and at least a little bit nicer to work with. So as a sample here, I have 6x to the fourth plus 20x cubed minus 4x. I want to look at each of these three terms, and I want to see what is the greatest possible thing that's in every one of these three terms that I can pull out front of it. And when I say pull out front, I just want to be clear, we're not completely canceling this out. We're just pulling the same thing out of each of these three terms, and we are putting it in front. So I look at each of these three terms. First thing I know is that in every one of these terms, there is an x. So I know that that's one thing I can pull out from it. I also look at these three terms, and I see there's a 6, a 20, and a 4. Every one of those numbers contains a factor of 2. So I can pull a 2 and an x out of there at the same time. So when I do that, that leaves me with 3x cubed plus 10x squared minus 2, and it's that whole thing being multiplied by that 2x. When we get later on in the course, we will be doing a lot of work with factoring polynomials and finding things that make finding the x values that make polynomials equal to 0. So any simplification, any factoring that we can do at all to make solving that type of problem and being able to do that type of thing easier, it's going to go a long, long way. Another sample here, negative 3x to the fifth plus 18 times x to the fourth plus 24x cubed. I look at every one of these terms here, 3, 18, and 24. There is a common factor of 3 amongst those three things. There's an x to the fifth, x to the fourth, and an x cubed. Every one of those factors, every one of those terms contains at least an x cubed. So I can pull an x cubed out of there as well. And then there's also something else I can pull out. Typically, the term with highest power of x, we typically want to keep the number that's in front of that guy positive. You'll see as we go on later on in the course, you'll see why we want to do that. It just makes factoring overall a lot easier. So I can actually pull a minus out of every one of these three terms. And when you pull a minus sign out, you just change the sign that you have in front of that term. So here we have a minus right now. When I pull the minus out, that's going to become a plus. In these two spots, I have pluses. When I pull the minus sign out, those are going to turn to minuses. So I'm pulling a minus 3x cubed out of every one of these three terms. And that gives me minus 3x cubed times x squared minus 6x minus 8. Now, this is perhaps something that if you look at, you think that we may be able to factor this guy here more, and perhaps we can, but right now I just want to go over this easiest form of factoring. It's just pulling the greatest common factor out of each term. The most common use of factoring that we typically use overall, and we will be using in this course, is factoring a quadratic expression, which is a trinomial, has three terms, into the product of two binomials, two things with two terms. And what we're doing is we're taking something of the form ax squared plus or minus bx plus or minus some constant c. And we want to write this as something times x plus or minus something else times something times x plus or minus something else. So some general rules, things to keep in mind as to how do we factor these things here. As far as the numbers in front of the x here, whatever these two blanks are here, those things need to multiply out to this capital A here. So if I give these things, say, give names of little a and little b, we want little a times little b to equal capital A. Here we have signs plus or minus, and then these two things here, I'll call this C and call that D. We need the product of little c and little d, including the signs, to multiply out to whatever capital C here is, including the sign as well. So I'll say little c times little d has to equal capital C, and the implication is you're matching the sign as well. And then when we do ax times the d plus or minus the bx times the c, we have to have that match up to the b value here. So I'll say plus or minus AD plus or minus BC has to equal capital B. So we're going to essentially go through all this with a couple sample problems here, and we're going to see how these things will break down. So here I have x squared minus 10x plus 21. And I want to break this down into the product of two binomials. So set up my parentheses here. There's an x there, and there's going to be an x there. Now, I look at the number in front of my x squared. There's nothing written here, but secretly there's a 1 there. So whatever these numbers in front of the x's here are going to be, those two things have to multiply out to a positive 1. Now, while it is possible that it could be minus 1 and minus 1, I can promise you right now, any problem you see from me, I should say 99% of the problems that you'll see from me, it's not going to be a minus 1 and a minus 1 there. They're both going to be they're both going to be positive 1s. Excuse me. So we can write a positive 1x and a positive 1x. You don't even have to write the positive 1. You could just write x. Now I need to fiddle around with what's the sign that's going here and what are the numbers going there as well. And in some cases, it's really easy and really straightforward to figure out what the signs are going to be. If you look at the sign in front of C, of your C value here, which in this case is 21, we see that we have a plus here. If the sign that's in front of your C value is a plus, then that means that the signs you have over here and over here are going to be the same sign. They're either both going to be pluses or they're both going to be minuses. Now, what is the sign that we're going to put there? The sign is whatever you have in front of your b value. So here's a plus. That tells me that I'm going to have the same sign here and here. What's that sign? It's going to be that minus sign. If the sign you have in front of your c value is a minus, then you are going to have one of these guys with a plus here, and then the other one with a minus there. And then that gets a little bit more tricky, because then you have to figure out what number goes with which thing and where should that minus sign go. But this first one, it's really nice. We know that it's x minus something times x minus something. The question is, what are those two somethings? I need two numbers that multiply out to 21. And when I do 1 times a number, and then 1 times the other number, I'll get 10. So, in other words, I need two numbers that multiply out to 21 and add up to 10. So if you think about the factors of 21, it shouldn't be too long, or it shouldn't take too much time to figure out that those numbers are going to be 7 and 3. And because we have coefficients of 1 here on these x's, and because these are the same sign, we don't care where we put the 7 or where we put the 3. So I have 1x minus 7 times 1x minus 3, or more commonly written, x minus 7 times x minus 3. I wrote these in reverse order here because the order in which we multiply things does not matter. This was a very basic, a very low-level type of factoring problem here. This next one, a little bit more involved, a little bit more complicated. So here I have 3x squared minus x minus 10. Again, it's going to be the product of two binomials. This one is a little bit more involved. I'm going to have an x, I'm going to have an x. Note that the sign in front of my c value is a minus. That tells me that one of these factors is going to have a plus here, and the other factor is going to have a minus here. The question is, which one goes where? Now, I have 3x squared. It's not as nice because there's not a 1 there, but it's still not that bad for figuring out what are these numbers going to be here. Because the only way that you can get 3 is to have a 3 and a 1. There's no other way to come up with 3. If you had something like 4 or 6, then you have 6 and 1, or 2 and 3. For 4, you have 1 and 4, or 2 and 2. So there's a couple options you could have to play with. But 3x squared, not too bad. It doesn't matter where you put the 3 right now. So I'll put it up front here, and then this is just a 1, which I'm not going to write. So I have 3x, and then something, and then x, and then minus, or and then x, and then something else. So I need two numbers that are going to multiply out to a negative 10, and I need to choose these numbers such that if I take one of the numbers and multiply it by 3, and then add the other number, I'm going to get a negative 1, because outside, 3 times something, inside, something times 1. So 3 times something plus something else has to give me negative 1. So let's think about factors of minus 10. I can have positive 1 and minus 10. I could have negative 1 and positive 10. I could have negative 2 and positive 5. Or I can have negative 5 and positive 2. This does require a little bit of trial and error. Trying those combinations and seeing which one works. But I'll tell you right now, the one that does work is 3x plus 5 and x minus 2. If you FOIL this out, 3x squared minus 6x plus 5x minus 10. And the minus 6x plus 5x gives us minus x. So that is what this particular guy breaks down into. Once again, a little bit nasty, but not too bad in the grand scheme of things that we could see. Sometimes some trial and error does indeed come into play. So a common enough factoring formula that we use and we'll see, a squared minus b squared is equal to a plus b times a minus b. This is referred to as the difference of two perfect squares. So you can either see something plus something and then that first something minus that second something. And if you keep this formula in mind, just really quick and easy, okay, take the first thing, square it, take the second thing, square it, take the difference of those two things. This is an example of how it sort of gets used in the reverse way. If you're given 4x squared minus 25, how can you factor this thing? Well, 4x squared is equal to the quantity 2x squared, and then minus 25 is 5 squared. So this right here is my A. This right here is my B value. So then we have 2x plus 5 and 2x minus 5. And those are the two factors that this thing will break down into. Some other formulas that are out there, it's good to sort of have them in the back of your head. Not something that's necessarily going to be used a lot, but the sum of two perfect cubes, you can break that down as a plus b times a squared minus ab plus b squared. And then we have the difference of two perfect cubes, a minus b times a squared plus ab plus b squared. Again, they're out there. It's good that you see them, but not something that's really commonly used in a course like this. So what if we have a polynomial of a degree higher than 2, like say 3, 4, something like that? How can we pull out a common factor? Or how can we start to factor something like that? Those can get really ugly. They can get near impossible to do with the level that we're at right now. But one thing you can do is try to look for a common expression and you want to group terms and then factor out that common expression. I'll show you what I'm talking about here in a sample problem. So here we have 2x to the 5th minus x cubed plus 6x squared minus 3. So what I'm going to do is I'm going to look at these first two terms as one group and then the second two terms as their own group. And what I'm going to do is I'm going to pull out the greatest common factor for each of these groups. Here I have a 2x to the 5th minus x cubed. Each of those terms in there contains a common factor of x cubed, so I can pull that out front here. The 6x squared minus the 3, each of those contains a common factor of 3. So I can pull that common factor of 3 out. And that leads me right here. X cubed times 2x squared minus 1 plus 3 times 2x squared minus 1. Well, if you look at these two things here, they each contain that common factor of 2x squared minus 1. So what I can do is I can pull that whole thing, looking at it as one factor, I can pull that one whole common factor out of each of these two terms, and that is then going to leave me with x cubed plus 3 times 2x squared minus 1. This is not very easy to do. I'll be honest with you. It does take a little bit of practice. It does take a little bit of looking at it. But the more and more you work with these kinds of things, the more you'll be able to recognize that, oh, hey, there's a common thing going on if I group these particular terms together. This is something that's, again, handy to know. You may have to use it every once in a while, but is it the most common thing that we're going to be doing in this course? Not so much. So this wraps up our video on factoring polynomials. In the next video, we are going to go over quotients. Quotients of polynomials, quotients of radicals, and how do we simplify those things. So if you have any questions or comments, please be sure to reach out to me. Throw out the bat signal, chuck a rock my way, send me a text, whatever you have to do. Otherwise, until the next video, take it easy, guys.